All right, John Blackwell here to give you a real quick run through on how to analyze a spectrum in Maxim DL so that you guys can achieve a proper focus for the telescope system, and also do some preliminary studies on your spectra overall. So here we have Maxim DL Pro 5 opened. I assume that you're familiar with that, and fits images and all that happy stuff. I'm going to literally just open the image that was sent to me of Vega, and I'll zoom out a little bit and you can see your spectrum nice and bright. The very first thing you want to do is look up a type A spectral type star and take some images of it. And while you're taking images of it, you need to keep the information window open. So here is the information window menu pick. It opens up a window called the information window, and you want to make sure that the mode is set to aperture. And then as you move your aperture around on the screen, you'll see that the numbers for pixel value maximum and minimum for this particular image have maxed out at 64,000, which is in the nonlinear range of your CCD chip. So it's too bright. You need to take shorter images, and since you probably have this down to pretty short exposure time, you probably want to find a fainter star. Try to keep the values between 10,000 and 40,000. The astronomers of the world call that the linear range of your CCD. Once you start leaving that range, either too bright or too faint, then readings become inaccurate. If they're too faint, you're in the noise floor. If it's too bright, then you're close to what is called full well capacity, and that won't be useful. So let's make sure that you keep an eye on that. Once you've achieved an image of a star that is inside that range for pixel values, you're going to want to rotate your image. So edit and then rotate right. It rotates at 90 degrees to the right. You'll see that there are two spectra of the star here, one on the left and one on the right. The one on the left is fainter. That's a secondary spectra, perfectly normal, but is not the spectra that most astronomers want to use. They want to capture as much light as possible, typically, because they're looking at very faint objects. So the spectrum that we will usually look at will be the one here on the right hand side, and that is your primary spectrum. To achieve focus, you need to open up Maxim DL's graph window. So under the view menu, there's this thing called graph window. Click on it and it opens up the graph window. Make sure that you have selected the horizontal box option, at which point you can draw a box around the spectrum of the object in question, just like that. And you can see that this indeed has a nice little curve to it. It even looks Planck curve-like, which is congratulations, that's pretty good. But you'll also see that there are no absorption lines in that curve, which means that we have not achieved a perfect focus yet for the system. And that's fine. That is your job, is to achieve focus. So moving the focus in or out, pick one direction and move out. And if it just gets worse and worse, things get blurrier and blurrier, then you know that you should go back to the beginning point and move in. Start taking picture by picture, and for each picture, open up a graph window of it, draw a box around the prism spectrum, and then see if you get absorption lines. The absorption lines will eventually be pretty dim and hard to see, not too deep. Your goal is to make them as deep as possible, and once they are as deep as possible, write down that focus point for your telescope system and memorize it, and don't lose it. Also write down the temperature inside the dome. That's important because temperature actually influences greatly spectroscopy. Your telescope has a built-in temperature compensation system. I'm pretty sure it has that built in, but for spectroscopy, even nanometers make a huge difference in terms of focal point. So you have to be very slow and methodical here. Interestingly, because this is such a bright object, if we draw a box around the fainter of the two spectra here, right there, you start to see some absorption lines forming, and these will get pretty deep if we do it right. Okay, so just some pointers. Hope that helps you out, and clear skies.